Today, we're going to continue to go over some of the rules and formulas that we covered in day one. Um, you can find this in day one, uh, the day one slides of Google Classroom. We're going to start with rules and formulas two. Just a friendly reminder, there's kind of a lot of formulas on this, and it's sort of a lot of topics, I think, combined into one day. So if this is a little bit overwhelming, um, don't worry too much about trying to remember all of this. But these are just some helpful rules and formulas that will help you on the test. So we're going to talk about the equation of a circle, how to complete the square. We're going to go over exponential formulas, what zeros of polynomials are, and a little bit about sine and cosine and how they're related. So this is a lot of different topics, all sort of presented to you at once. Now, if you know about circles and exponential formulas already, and polynomial functions, this shouldn't be too bad. Uh, but if this is brand new to you, it might take a little bit of time to fully feel like you've mastered it. So this first equation is um, this first equation is the equation of a circle, and this is the general equation of a circle. So HK is the middle of the circle, and R is the radius of that circle. Um, if it's like x minus 3, y minus 2, if it was both a minus and a minus, like this, y minus 2 equals, I'm just going to say r is 5. You can graph that on Desmos just fine, but the center is HK. So the center is actually positive 3, 2. So that's the center. So just think opposite signs when you're dealing with the center of a circle. Okay, so that is just the basic form of the circle. You're probably going to be given an equation like this, and you can just plug it right into Desmos. It'll show you the center, and it will also show you that the radius is 5 on that circle. So a quick sketch of that would be just do 1, 2, 3, 1, 2. There would be the center, and then the circle would be like this, and then the radius is just 5. So that would be 1, 2, 3, 4, 5, 6, 7, 8. So that would be there at 8. Again, that's just kind of a quick sketch of what it would look like. Now, they don't always write 5 squared. They might write it like 25. And it might say, like, what is the radius? Well, the radius is the square root of 25 because r squared is what this equals. So we would write r squared equals 25 and then find the square root of both sides, and we'd get r is 5. Okay, let's see if they tell us another example here. So here it says a circle's graphed in the xy plane. It gives us the center and it gives us the radius. So our equation again is x minus h quantity squared plus y minus k quantity squared is equal to r squared. So the center is negative 2, 3. So that's the x and that's the y. And so this is x minus negative 2 squared plus y minus 3 squared equals the radius of 5. So we write that as 5 is r and then squared. So now this becomes x plus 2 quantity squared plus y minus 3 quantity squared equals 25. And then we just match which equation that would be. So that one's going to be, let's see, we're going to be D. Okay. All right, that just says our answer is D. Okay, completing the square. Completing the square can be a little bit tricky sometimes. Um, Basically, what we're trying to do when we complete the square is our quadratics are written in this form like this. If we get rid of the y equals, then we can set it equal to 0 like that. And then basically when we factor a quadratic, we want to factor it so it says like x plus something times x plus something else, or it could be a minus or a minus. But that's how we factor something. So if we had something and our final answer was this for the factored form, then we would know that the graph crosses at x equals -5 and x equals -3. So that's what we find out when we factor something. But this question isn't asking us just to factor something. It's asking us to factor it so it's like something like this, like something like x plus 5, quantity x plus 5 times quantity x plus 5, which is x plus 5 quantity squared. And that's how we were completing the square. And we do this a lot when we try to find things in vertex form. Okay, so that's sort of an overview of what factoring is and 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 the general form of a quadratic. Let's go over now this next part. I think this next part is a little bit tricky to understand because there's no numbers really. It's just rules. But what we do is if we have something in standard form, first we move this c to the other side. So we move our regular number to the other side. Now, if we use this example, we get minus c, and here they give us a positive c, but that doesn't really matter. We're just saying c is our constant number. So whatever it was, we move it over. It could be a positive, it could be a negative. We'll just move it to the other side. So that's step one. Step two is we're going to add a little bit of an amount to one side and a little bit of an amount to the other side. And we're allowed to do that because with algebra, we can add the same number to both sides and then it still makes a true statement. So that number is whatever b is, the coefficient in front of the x term. We divide that by 2 and then we square all of it. So that's what the value is. We're going to add a little bit of something to the left and then do that same thing on the right side. So that's what b over 2 quantity squared to each side stands for. Then when we've done that, we rewrite all of this stuff on the left side like this. So when we rewrite it, now it's like something like this example where we had x plus 5 times x, quantity x plus 5 times quantity x plus 5 equals quantity x plus 5 squared. So what we're doing is this is called creating a perfect square. When we have two of the same binomials being multiplied together, we write it as squared. And so that's what we're doing. We're changing this into this. So when we rewrite it like that, we just write the x squared now is just an x. It's a plus whatever b over 2 was. So we got to figure out what b over 2 was. And then we square all of that. And then the right side just stays the same. Um, and then that's it. We just rewrite it like this. That's our final answer. This is a little confusing without numbers, so let's go to an example. Let's see if we have an example here. This says the equation of a circle. We may not have an example for this one. Just a moment. Let me see if I can find us an example that's not on the PowerPoint. So I'm just going to pause the recording here. Okay, so here's one that's not on the PowerPoint. I just copied this problem so we could go over an example. So we're just going to do the same steps as from above. So the first thing we're going to do is we're going to isolate the constant to one side. So this is x squared minus 12x. I'm going to leave an empty space here. And I'm going to leave an empty space, equals -11 plus something else. And that's just sort of a reminder that we're going to add something here and we're going to add something there. Now, that something is b over 2 quantity squared. So in this equation, a is equal to 1, because we have 1x squared, b is equal to negative 12, and c is equal to 11. So now we're going to do this. We're going to say this is um, b over 2 squared. So negative 12 over 2, and we're going to square all of that. So that's negative 6 squared, and that equals 36. So now we're going to add 36 over here, and we're going to add 36 over here. Now, if we factor this using the AC method, we're going to get a perfect square. But we don't even have to use the AC method to do that. So the AC method would be when we do A times C is 1 times 36, figure out what times what equals 36, and adds up to negative 12. That's the regular method of factoring. But if we go up here, it tells us we don't have to do all that. We just are adding b over 2 squared to the left, and we're adding b over 2 squared to the right. And then we rewrite this as x plus b over 2 quantity squared. So we don't have to factor with the AC method it's basically what I'm getting at. So now we just write x plus b over 2. B over 2 was negative 12 over 2, or negative 6. So I'm just going to write x minus 6, and that's quantity squared, equals negative 11 plus 36 equals 25. So now if we write this as a y equals equation, we can write this in what's called vertex form. So for this is more of a simple example. I'm just gonna leave it like this. I think if we graph this in Desmos, it'll still show us the right answer. Let me see if I can do that for us really quick here. Let's see. I'm just gonna type the first equation into Desmos, and then I'll share my screen with all of you in just a moment. So typing in the first equation, then I'm typing in the second equation, which is x minus 6 quantity squared minus 25. Okay, all right. So here's what's happening is all of this equals 0. If you type this in the Desmos like that with it equals 0, you're not going to get anything out of Desmos. You have to write it as a y equals. So that's the first thing you do, right? This says y equals all that stuff. Now, when we set this equal to 0, we're going to minus 25 on both sides. And we get x minus 6 quantity squared minus 25 equals 0. And we just rewrite it like y equals. So I'm just going to write equals y just to save some time. So if you graph these in Desmos, you're going to get the exact same line on Desmos. And let me show you here. So here's the line that they gave us. It's a quadratic, it's a parabola. And now this is the same thing, but in vertex form. And you might be wondering, well, why do we even need to know the vertex form? The vertex form just tells us where the vertex is. So this is the vertex is at 6, negative 25. So that's what's so helpful about vertex form. It just tells you right here is at 6, negative 25, 6, negative 25. That's a little bit more difficult to find that with the equation that they gave us. Okay, so we're going to do the same process again, but this time we're going to do it twice. So this gets a little bit more complex because we have x's and y's, and we're going to change this so we have an equation of a circle written in the form that we went over from earlier. So the equation of a circle again is x minus h squared plus y minus k squared equals r squared. Okay, so we have to condense these x's and these y's so that they look like that. So here's what we're going to do. We're going to write this out. We're just going to do one part at a time. There's a little bit of something we're going to add for the x's. And there's a little bit of something we're going to add for the y's. And there's our 15 that they gave us. And we're also going to add that little bit of something for the x's on the left, on the right side, and a little bit of something for the y's on the right side as well. So we're going to do this same process. We're going to say b over 2 and then square that. So let's focus on the x's first. B is -4. That's -4 over 2, and we're going to square it. -4 over 2 is just -2. We're going to square that. Very important that this is +4. Anytime we square a negative, that's positive. If you don't put parentheses in, sometimes your calculator will say it's negative, but it's always a positive when we square a negative number. So we're going to add 4 there, and we're going to add 4 there. We can do the same thing for the y's. B over 2 quantity squared is 18 over 2 squared equals 9 squared, and that equals 81. So we can do 81 there and 81 there. Now, when we rewrite this, we're going to write it in the form x plus b over 2 quantity squared for the x part. And for the y part, it's going to be y plus b over 2 quantity squared. And it's going to equal all of this over here on the right. Let's just finish this right side right now. So 15 plus 4 is 19, plus 81 is 100. Okay, so b over 2, we're going to go back now. B over 2 is just -2. So it's not the squared part, it's what just b over 2 is. So this is x minus 2 quantity squared plus just what y is 9, y plus 9 quantity squared. That equals 100. Now it says, what's the center of the circle? So it doesn't ask us about the radius. That's kind of nice. It just wants to know what the center is. So the center is HK. And so the center is going to be +2, -9. It's going to be B for that one. Okay, so that's how we complete the square for a circle. Doing the same thing twice, once for the x's, once for the y's. Okay, and this is just another explanation down here from the slides. Okay, exponential formulas are next. So exponential formulas, sometimes they give us formulas that um, they describe growth or decay. And so this is our formula for growth or decay. A is the starting amount that we're given. P is the percent increase or decrease. N is how much time went by. So P basically it's over 100 because that's what we have to do to write anything as a percent. So if we wanted to write 50%, it's just 50 over 100 is 50%. And as a decimal, it's 0.5. Be careful, 5% is 0.05. So those are very different numbers. Just be careful when you do that. So if you notice we have a 1 and it says plus or minus, that's saying 100% plus whatever percent that it gives us if it's growth. If it's decay, it's minus. Do green for growth. red for decay. So if it's growth, we do a plus there. If it's decay, we do a minus there. And that's it. We just usually plug in those values, but we have to figure out what the percent is or what the time interval is. Usually it's one variable that we still have to find from an exponential formula. And normally these are written in word problems. All right, let's look at an example. It says a new computer is estimated to depreciate at a rate of 9% per year from the previous year. The function C models the value of the computer T years after its purchase. Which of the following could define C? Okay, so if we look at our exponential model again, it was y equals a times 1 plus or minus the percent. I'm just going to write percent like that. All to the power of. Now our time function, sometimes it depends on if it's compounded or not. So n is the time interval. Here it didn't really say what x was. I'm just going to write t because t stands for time, and we usually write it like that anyways. So A is our starting amount. All the A's are the same. Starting amounts are the same. But now we have to figure out what this means. Depreciate at a rate of 9%. Depreciate, it's if something depreciates, it goes down. If it appreciates, it goes up. So a depreciation rate of 9% means it's going down 9%. Now you might be thinking, oh, okay, well, it's just the 9% here. That's not correct. Be very careful that you do the 1 minus the 9% if it goes down. So far we know A. I'm just going to write A for now. And then 1 minus 9%. And then T years. It doesn't tell us how many years. We'll just write T. So this part is the most important part because that's the only part that changes from our multiple choice. 1 minus 0.09 is equal to 0.91. So our answer is C. Now, for some of these, it'll tell you like 5 years, 10 years. Usually it'll tell you the rate. It'll usually tell you if it's going up or down, but you have to know some vocabulary about what it's telling you. Is it going up that percent or is it going down? So if something goes up by 9%, we actually multiply by 109% or 1.09. If something goes down by 9%, we multiply by 0.91. Anytime we multiply by a number greater than 1, it gets bigger. If we multiply by a number less than 1, our overall value gets smaller. Okay, so that's that one. 0.91. And the zeros of polynomials. Okay, this one's not too bad. For the zeros of a polynomial, we basically just need to factor it and then set each of those factor groups equal to 0. And the zeros of a polynomial means where does it cross on the x-axis? So before we were looking at quadratics, where it was just like a U shape or an upside down U shape, and we'd have 2 answers for that. But now if we have 3 answers, and our polynomial would be a 3rd degree polynomial, and it would look something like that. So in that case, we're going to have 3 answers for what x is. I'm just going to make some up right now. I'm just going to say this is -5, this is 1, and this is 6. So if we wrote that out in factored form, it would be x plus 5, quantity x plus 5, times quantity x minus 1, times quantity x minus 6 is equal to 0, or we just say y equals that. So then what we do is, in order to find these numbers, is we just set that equal to 0, that equal to 0, and that equal to 0. So you get x plus 5 equals 0. X is negative 5. X minus 1 is 0. X is equal to 1. X minus 6 equals 0. X equals 6. So for all of these, that's all you have to do. Now, if we had another one that was like, if it was like x on the outside, and then it was like x plus 10, x minus 2. If we had another one that was like that, we would say this is x equals 0 for this one here. And then we'd say x equals negative 10 and x equals positive 2 for the rest of these. So that's what we do when this is on the outside. We just set it equal to 0. And there's some different key terms that we need to know for these. We need to know the term 0 is one of them. Solution is another one. Root and x-intercept. So those are all the same thing for describing what the zeros of a polynomial are. So for this one, it says, which of the following values is not a solution to the equation? So this one's x equals 0, x equals 3, x equals negative 4. So now it just wants to know which of these does not equal that. So we can cross off the ones that it does equal. And so D is our answer. Okay. All right, the sine cosine relationship. We usually just have one problem that's about this. Um, it's kind of just like a memorization problem. But basically, it says that if we have a right triangle and we say that here's our right angle, here's A, here's B, that's telling us that angle A and B are complementary. That means that plus that, even if they're different, I'm going to write them so they are different. It just means that plus that equals 90. That's what complementary is. Then sine A equals cosine B, and cosine A equals sine B. Let's take a look at what that means. I'm just going to put some numbers here. I'm going to make this a 2. Actually, do this. We'll do 3, 4, 5. So for sine, cosine, tangent, this is important to know. The SOHCAHTOA, like that. It's for sine, cosine, tangent. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So whatever angle we're looking at, we use these rules, and this is kind of a shortcut method. Um, SOHCAHTOA kind of helps you to remember these three equations if you remember this acronym. So if you know this is maybe going to be on more than one question on the SAT with sine or cosine, possibly tangent. So this is getting into some trigonometry now. Okay, so for sine A, let's just write what sine A is. So here's angle A, and sine of that angle, opposite over hypotenuse. So the opposite of this is 4, and the hypotenuse is 5. So we write this like this. Sine A equals 4 over 5. And then cosine of B, that says that equals that. So we're going to say cosine of B. Cosine is adjacent over hypotenuse. For B, adjacent is the one next to it. So that's 4. The one next to it can never be the hypotenuse, and the hypotenuse is always across from the right angle. So the one next to B is 4, and the hypotenuse is 5. So that's just saying that those are equivalent statements. Sine A equals cosine B. Then if we look at cosine of A, sometimes we write it like this with the parentheses. cosine of A is adjacent over hypotenuse for angle A. That's 3 over 5. And then sine B should also be 3 over 5. Sine is opposite. 3 over 5 is hypotenuse. Okay, so let's look at an example for these. Um, that might that might be a little better than just remembering this rule. So some of these slides have so you have to remember this exact rule, and I think that's a little bit challenging to remember that. But um, well, maybe not. Maybe just if you know that sine of sine of the one angle in the complementary angle set is equal to cosine of the other angle in the complementary angle set. I think if you know that, it's probably good. Okay, so now it says in the right triangle XYZ, cosine A is 8 over 13. Now they kind of wrote this a little weird. They should have written it like this, like that's uppercase A. But that's fine. That's fine. Um, well, no, that's actually correct. Yeah, they can write it that way. Cosine of that angle is equal to 8 over 13. So cosine of A, so cosine is adjacent over hypotenuse. So that's the angle next to it is 8 and hypotenuse is 13. So it says cosine of that angle A degrees, we don't know how many degrees it is 8 over 13. Now it says, what's the value of sine B? Well, sine B should also be 8 over 13 because that's our relationship that we figured out is cosine of the one angle equals sine of the other angle as long as it's not the right angle and it's in a right triangle where the two angles are complementary. So this one's just 8 over 13, kind of easy. Um, Now you can actually figure out what that angle is with your calculator too. So you might have one question about this for your calculator. So we take the inverse of it, and I like to think of it as like multiplying by the inverse, and it kind of crosses that out. That's 8 degrees is inverse cosine 8 over 13. So now we do the inverse cosine. That's second cosine on your calculator. 8 over 13, close the parentheses, and we get 52.02 degrees. So that's what angle A is equal to. I know that wasn't asking us for that, but that's just another tidbit of information for you about using sine and cosine and using the proportionality to figure out the exact angle measures. Okay. All right. So that's it for rules and formulas, uh, rules and formulas 2.